Let's take a look at number 55 of leetCode jump game. Given an array of non-negative integers, you're initially positioned at the first index of the array. Each element in the array represents your maximum jump length at that position. Determine if you're able to reach the last index. Yeah, so for example, like this, we can jump to the last end. Actually, we have done a similar questions. Yeah, it's reach 35, jump game 2, which is the exact problem, except that we are given the step, not the boolean about whether we can reach the last element or not. Yeah, actually, the first thing is that I can just modify the solution of a jump game a little bit and get the result, I think. So if you haven't looked at the video of 45, please search on my channel. There is a detailed video about number 45, right? Okay, I'll just first copy paste the solution. Okay, the original solution is very simple. We use a dynamic programming solution. We will help a DP array to hold the minimum amount of steps moving to the specific index. Okay, so if there's only one number, so actually it should be true, right? It definitely can be reached. And then we use a DP array to count the steps, and then we check all the indexes and update it, and when k is reached, we return the dpk, right? Yeah, if k this, we return true. If not, return false, right? I think this should work. Well, there's a mistake, sadly. The thing is that we made a mistake, say 0, 2, 3, 0, 0, and 2, 3. The problem is here. We traverse through all the numbers. Okay, we traverse all the numbers. If this actually could be ignored. For k equals the next one, we will update the minimum of the steps. If k equals last one, return true. I'm curious if the solution means if the input is like 1, 0, 2, 3, what will be our solutions on the 45 return? It will infinity. So actually, but yeah, the problem says I can assume that they always reach the last index. Yes, but here there's no such we cannot assume that. So actually, our original solution on jump game cannot be used. Could we tweak a little bit? Yeah, actually, the problem is for the for loop here, right? We traverse through all the numbers, all the indexes, but actually we cannot do that. For this specific problem, we don't need to get the minimum steps, right? We can just say we can get it or not. So we can try another way. Okay, if it's 1, of course, actually we can say smaller than 1 is true. Okay, actually we can just traverse through all the digits, but not all, the maximum, until the maximum, right? Okay, for the first number, it's true 2, so we can actually get to reach to this index, so we can loop through all the digits here, indices here, and expand the maximum index, right? If we had 3, we can expand the index to 4. Yeah. So that becomes very simple. Let's say let max index. Currently we say it's 0. As okay. So okay, let I equal 0 while I is smaller than max index. If this is true, we will update the max index, right? So max index equals math I will plus, don't forget this is very important. Okay, so we can we try to expand while looping. Max equals math max index. The next max index should be I plus nums I. If max index is bigger than or equals to num minus 1, we should return true. And finally, here, if not, return false. When everything is done, return false, right? Let's run the code. Time is every number is traversed maximum only once, so this is worst. Space, we only use several variables. Yeah, we don't use any array or matrix, so it should be constant. Submit. Yay, we're accepted. Actually, the original solution has some flaws. This solution only works that we can assume that always reach the last index. If there's not, it would gonna be infinity. We can actually tweak these solutions a little bit with the solution here, right? We will just narrow down the keep an extra a maximum and use this for loop again. Actually, we can get that. Combine these two solutions and get to better solution. Yeah, hope this helps. So that's all for this problem. See you next time. Bye bye.